Welcome to AP Calculus BC video for skill number 208. I can find slopes of secant lines and estimate the slope of tangent lines within context. Alright, with this skill we are just getting started into the ideas of calculus, and what we are trying to do is find the slope of a secant line on a function from a to h. And what that means is if I have a function, here's my curve, we're going to find the slope of the secant line from a to a plus h. So here is a plus h, and we're looking for the slope of the line that connects those 2 points. It becomes calculus when we start to take that distance from a to a plus h and make it skinnier and skinnier until it's infinitesimally thin. So we use the formula that I've written down here. There's a couple different ways to write the formula, but the basic idea is you're going to evaluate the function. What is the y value at your second coordinate? Subtract the y value at your first coordinate, and then divide that over your x value at the second coordinate and your x value at the first coordinate. So what we have is more or less a slope formula. So let's take a look at it in example 1. Example 1 says find the slope of a secant line 2 f of x equals x squared minus 2x from 3 to 3.1. Repeat for 3 to 3.01. I think it got chopped off. 3.01. And estimate the slope at x equals 3. So what we're going to do is use the formula from above and plug in our values of 3.1 and 3 and evaluate it. 3.41 minus 3 over 0.1. And I'm a huge fan of using your calculator to make this sort of job easier. I would suggest taking a look at the vars button and scrolling to function and then grabbing y1. And if you have this, if you have the equation plugged into your y1, then it makes this job easier. And I'll talk about that more in class. But from there, what we can do is plug it in, and it spits out an answer of 4.1. If we did this process with the calculator, then we could very quickly spit out the answer to the second part, which is from 3.01 to 3. And we're going to plug 3.01 into the function, and then 3 into the function, and then divide by 3.01 minus 3. And it gives us another answer, which would be 4.01. And you can see we're approaching, first we're at 4.1, 4.01, so it appears to be approaching 4. So our estimation, our algebraic estimation of the tangent line slope at 3 is 4. Which means if we were to graph this function, maybe it looks something like this. At x equals 3, the slope of that line probably is about 4, based on our secant slopes.
I feel.
Do you feel alive?
I feel happy of myself.
I feel happy of yourself too.
Alright, example 2 is a very similar problem. What I've done is I've changed the function. So what I would suggest is you go grab your calculator and under y equals, place y1 equals root x plus 7 into the function. And they're wanting the slope of the secant line PQ if x is at 5, and then we try q at 3 different spots, 4.9, 4.99, and 5.01. And so we have some sort of root function that's been shifted left 7 units, and we're asking for what is the slope from 5 to 4.9. So what is the slope right there? And the way I do that is with the calculator, I press vars and I scroll over to function and I select y1. And on my home screen, this is what I type: y1 of 4.9 minus y1 of 5. And you can grab that y1 again by using your vars function y1 button. type this all out, and it spits out an answer, and that's the first question. Then we do it again for 4.99. We get another value, and as you can see, it's not approaching any sort of clean number. We do it again at 5 to 5.01. So we've kind of trapped what the slope is between 5, or at 5. It's between these two values. So what I said is the true value is between this one and this one. So it won't always be clear, and we will eventually find a way to calculate it exactly.
Everybody, I know you can believe in yourself. If you believe in yourself, you will know how to ride a bike. If you don't, you just keep practicing. You will get the hang of it, I know it. If you keep practicing, you will get the hang of it, and then you can get better and better at it as you do it.
Right, in example 3 we're doing the same thing, except instead of having a function we have a table. And the AP exam is a big fan of making sure you can do this with a table as well. So what we have is a table of values, your input along the top, so x, and then your output on the bottom, x, y. And it says use the table to estimate the slope of the tangent line at x equals 2. So what we can do is we can say what is the slope from 1 to 2, and then what is the slope from 2 to 3, and then if we average those two, we're going to have an estimate of what the slope is at 2. So the slope from 2 to 3 we can calculate by f of 3 minus f of 2, so 24 minus 20 over 3 minus 2. So we get 4 over 1, and that's 4. Then we do the same thing for the slope from 1 to 2. So f of 2 is 20 minus f of 1 is 15. That's 5 over 1 is a total of 5, and we average those two values to get an estimated slope of 4.5.
Thumbs up, everybody!
All right.
For rock and roll!
All right, this concludes Skill Video 208. Thanks for watching.